What if we could borrow a fish's secret powers for just one day? Imagine this. Team RAR versus the fastest fish in the world in an epic underwater race. Could we win? It sounds like a crazy challenge, right? But to even stand a chance, we would need some serious upgrades. We couldn't just use our human bodies. We would need to understand the incredible engineering that makes a fish a true master of the water. Fish aren't just simple swimmers. They are perfectly designed aquatic athletes. Their bodies are built for speed, survival, and total domination of their underwater world. It's time to dive in and figure out exactly what makes them so awesome. Let's get this straight. Fish are not primitive or simple. They are high-tech living machines, and every single part of their body has a purpose. Think about their shape. Most fish have a special streamlined body, which is called a fusiform shape. This means they are pointed at the front, thickest in the middle, and tapered at the back, kind of like a torpedo or a race car. This design is no accident. It's the ultimate secret to cutting through the water with almost no effort. It allows them to slice through currents, chase down their next meal, or make a quick escape from a predator without wasting any precious energy. This torpedo-like shape is also a masterclass in stealth. When you're trying to sneak up on something, or hide from something bigger, you want to make as little disturbance as possible. Their smooth, curved bodies create very little wake or drag in the water. This means they can glide silently, almost like a ghost, appearing out of nowhere. It's the ultimate camouflage trick, using physics instead of just color. If we were going to build our own underwater race suit, we'd have to start with this super efficient shape. It's the first key to unlocking their incredible aquatic abilities and winning our challenge. So, the next time you see a fish, don't just think of it as a simple creature. Think of it as a high-performance vehicle designed by millions of years of trial and error. Every curve and every angle is optimized for life in the water. We're talking about a level of engineering that humans are still trying to copy for our own submarines and ships. The challenge is on. Could we even begin to replicate this perfect design? We've got a lot to learn before we're ready to race, but understanding their shape is the perfect first step on this wild aquatic adventure. Okay, so we've got the streamlined body shape down, but what about steering and moving? That's where a fish's fins come in. These aren't just floppy things on their sides. They are high-tech gadgets for movement. Think of the big tail fin, or caudal fin, as the motor. By swishing it side to side, a fish generates powerful thrust to propel itself forward. Then you have the dorsal fin on top, which acts like a keel on a boat, preventing the fish from rolling over. The fins on the side, the pectoral fins, are like the ailerons on a plane. They are used for steering, stopping, and even hovering in place. But it gets even cooler. These fins aren't just for moving forward. A fish can use its pectoral fins to make incredibly sharp turns, darting away from danger in a split second. They can angle them to brake suddenly, stopping on a dime. Some fish even use their fins to walk along the bottom of the ocean. Each fin is a multi-tool that gives the fish total control over its movement. For our underwater race, we wouldn't just need flippers for our feet. We'd need a full set of controllable fins on our back, sides, and chest to even hope to keep up with their amazing agility. It's like having multiple propellers and rudders all over your body. Now let's talk about their armor, the skin. Fish skin is way more than just scales. It's a miracle of biological engineering. First, it's covered in a layer of slime. I know, slime sounds gross, but it's actually a supersuit. This mucus layer protects the fish from nasty bacteria and parasites in the water. It also helps them heal quickly if they get scratched. And get this, it even reduces friction, helping them slip through the water even faster. So our race suit would need its own self-repairing, friction-reducing slime layer. That's some next-level tech right there. On top of that, the skin is their camouflage. The scales themselves often have incredible colors and patterns that help the fish blend in with its surroundings, whether it's a sandy bottom, a colorful coral reef, or the dark open ocean. Some fish can even change their color in real time to match their background perfectly. Imagine having a suit that could instantly switch from a seaweed pattern to a rock pattern. It's the ultimate stealth mode. Fish skin isn't just a covering, it's a dynamic multi-function shield and invisibility cloak all in one. What powers this incredible swimming machine? It's all about the muscles. A fish's body is mostly made of powerful muscle blocks called myomeres, arranged in a W shape along its sides. This isn't random. This shape allows the fish to create a wave of contractions that ripples down its body from head to tail. This powerful, flexible motion is what whips the tail fin back and forth, creating that explosive forward thrust. It's like their whole body is one giant coordinated engine designed for pure propulsion. It's way more efficient than just kicking your legs. Here's another epic secret. Fish have two different types of muscle for different situations. They have red muscle, which is full of oxygen-rich blood, for long-distance, steady cruising. This is their endurance muscle. But they also have white muscle, which is built for short, explosive bursts of speed. This is what they use to ambush prey or escape a predator in a flash. For our challenge, we'd need both. We'd need the red muscle power to keep up over the long haul, and the white muscle power for that final sprint to the finish line. Underneath all that muscle is the skeleton. A fish's skeleton might seem simple, but it's a masterpiece of lightweight strength. It's not heavy and dense like our bones. Instead, it's designed to be strong enough to anchor those powerful muscles, but light enough so the fish doesn't sink. The backbone is incredibly flexible, allowing the fish to bend and curve its body for those quick, darting movements. This combination of a strong, flexible spine and powerful muscles is the secret to their incredible agility. It's a frame that's built for twisting, turning, and winning. And how does this whole system stay fueled? With a super efficient heart and circulatory system. A fish heart is simpler than ours, with only 2 chambers. It pumps blood in a single loop circuit, from the heart to the gills to get oxygen, then straight to the rest of the body to deliver that fuel, and finally back to the heart. It's a simple, low-pressure system that is perfectly adapted for life underwater, where buoyancy supports their body weight. It's a streamlined power grid for a streamlined animal, ensuring every part of the fish gets the energy it needs without any waste. So, we've explored the streamlined shape, the high-tech fins, the supersuit skin, and the powerful engine inside. We've learned that fish have 2 types of muscle for different speeds and a lightweight skeleton for amazing flexibility. These aren't just cool facts, they are clues. They are the blueprints for winning our underwater challenge. Every part of a fish's anatomy is a lesson in brilliant engineering. From bones that grow continuously throughout their life to skin that can literally change colors, fish are packed with mind-blowing features that we are only just beginning to understand. Could we actually use these fish superpowers in real life? Absolutely. Think about it. Engineers are already studying fish shapes to design more fuel-efficient submarines and boats. Scientists are developing new materials inspired by the self-healing, friction-reducing slime on fish skin. Imagine a swimsuit that actively reduces drag or a boat hull that can repair its own scratches. These ideas aren't science fiction. They are inspired directly by the incredible biology of fish. The solutions to some of our biggest engineering challenges might be swimming in the ocean right now. This brings us back to our epic challenge. To race a fish and win, we would need to build the ultimate human upgrade. We'd need a suit with a fusiform shell, robotic fins for steering and braking, and a skin that changes color and reduces drag. We'd need a propulsion system that mimics their powerful body wave motion. We would have to become part fish. It's a huge undertaking, but that's what Team RAR is all about, pushing the limits and trying the impossible. The anatomy of a fish isn't just a boring science lesson, it's a playbook for future inventions. So the next time you see a fish darting around in an aquarium or a lake, remember the adventure. You're not just looking at an animal, you're looking at millions of years of research and development. You're looking at a master of hydrodynamics, a stealth expert, and a high-performance athlete all rolled into one. The question is no longer just could we win the race, but what other incredible secrets can we unlock from these amazing aquatic creatures? The ultimate underwater adventure is just getting started, and fish are our guides to a whole new world of possibilities.